Okay, I think there were some questions on this assignment. I wanted to make sure that you had access to kind of the correct answers and also kind of how to do some of these problems. On the front page, I think that the directions kind of threw some of you guys off. It says that x equals x sub 0, so if they give you x sub 0, they're telling you what to plug in for x. So you simply find the derivative, and then you plug in your value and you get your answers. So 1 is -1, 2 is a half, 3 is 141 over 2, it's weird, 4 is 1, 5 is 3/16, 6 is a half, and 7 is 1. And of course, let me kind of scroll through here. If you need to pause the video so you can kind of see my steps, go for it. I don't know how thorough all of those steps are just because I was kind of working it out on my own, so I don't really know. Let me pause this. Okay, where was I? Oh yes, we did the entire kind of front page there, so if you need to pause the video so you can see the steps, then you can do that. Next page. Okay, so they give us the original equation here. Velocity, of course, is the derivative of that. Acceleration would be the derivative of the velocity. Now here's the thing, is that the interval is from 0 to 1, so that's really kind of the only piece we're looking at. To find where it's moving right and left, you set the velocity equal to 0, which you can kind of see I did that over here, and I got -1/3. I went ahead and did the little chart, which, by the way the to do that is to take a number, plug it into the velocity equation, and see if you get a positive or a negative. Even though our time limits are between 0 and 1 seconds, which of course is, down this way. So it's at rest, meaning 0, a velocity of 0, would be never between 0 and 1. It does not move left between 0 and 1, and it moves right all the way from 0 to 1. The total distance is 5, and how I got that is I just went ahead and put in 0 to 1, because those are the limits they gave us, and the velocity doesn't change, so the particle does not change direction between 0 and 1. So I take these values and I put them into the position equation, which is the first equation, and I got -5 for 0 and 0 for 1, which that's 5 units difference, so the total distance is 5 units. For speeding up and slowing down, we look at our we first have to look at our acceleration, which in this case is a constant. So if you're going to make another number line, there isn't a number to put on there, because the acceleration, no matter what t is going to be +6 every time. So when you look at our the interval 0 to 1 second, it's positive here and positive here. Because they match, it's speeding up the entire for the entire interval and doesn't slow down in that interval. For 9, velocity is the derivative, acceleration is the derivative of the velocity. Again, set the velocity equal to 0. I went ahead and just, did I set up my calculator to do that? Yeah, because I got something funky, so that must be a calculator question. Stuck up my calculator, plugged in some values to kind of see where it was positive and negative. So it is at rest, or 0, at 1 and 2.73. It's moving left from 1 to 2.73, and this is a parenthesis because right at 0 is another turning point. So because that's a turning point, it's actually at rest at 0. And I don't think that says a 1, but at 0, I think there's another one. So that's why there's a parenthesis there. And then it's moving right. There should be a parenthesis as well, I believe. From 0 to 1 and 2.3 to 4. 4 is a bracket because at 4 it's continuing to move right. The distance was 50. I put in 0 to 4. Those are your sort of end caps, and then it changes direction at 1 and at 2.73. So I put all of these values into the position equation. I got these values, found the distances, and then added them up, and I got 50. Speeding up, you set the acceleration equal to 0, and then you put that on a number line, which is under here, and where the signs match is speeding up, and where they're different, it's slowing down. So you can see the answers there for speeding up and slowing down. Number 10, velocity looks like this. Acceleration looks like this. Actually, velocity is this guy right here, once you sort of simplify it down. And yeah, that looks funky. And some people, I think, didn't quite know what to do when you're setting it equal to 0. Did I write my steps? Well, it doesn't really matter. I can show you. you know that t cannot be 0 because that makes it undefined. So at 0, it's not even, at time 0, it's not that it's even at rest, it's that it doesn't even exist at 0, which is kind of a bizarre concept, but we're just talking about from 1 to 2 anyway on the intervals. And how we got that is that those were the endpoint, the end caps kind of that they gave us. Now think about this. If you plug in any positive number for t, positive times positive times positive is going to give you a positive number. Negative divided by positive would be a negative. So between 1 and 2, it doesn't matter what you put in there, they're all going to be negative. So it's not at rest between 1 and 2, it moves left between 1 and 2, and it doesn't move right. The total distance was 3/4 because I put in a 1 and put in a 2. There was no number to shove between there because it doesn't change direction between 1 and 2. And then you can kind of see my steps for the speeding up and the slowing down as well. Let's see here. For velocity and acceleration of the next problem, you can kind of see the answers there. Total distance traveled was 61. There's my steps for that. And it says during the first 3 seconds, which means we're going from 0 to 3. That's kind of how I did that. Let's see here. Car velocity, the acceleration to the nearest hundredth after 10 seconds. So I found the derivative and then I plugged in 10. That's what I did. You can kind of see my steps there, and I wound up with 0.61 feet per second squared. 13, filling the bucket. You can kind of see my steps there. It's asking at what rate, so I'm thinking derivative, is water leaking from the bucket after 2 seconds. So you find your derivative and you plug in your 2, and then you get 0.37 gallons per second. How long does it take for all of the water to leak out of the bucket? That's an algebra question. You take the original problem and you set it equal to 0, because we want to know at what point are there 0 gallons of water left. So we solve for t and we find out it's 25 seconds. And then it says at what rate is it leaking when the last drop of water leaks out? Well, rate tells me velocity, and so I've got my velocity equation here, and I know that it takes 25 seconds for all of the water to leak out, so I put 25s in for the t's, worked it all out, and I got 0. Which makes sense because there's no water left to go out, so when it says at what rate is the water leaking when the last one leaves, well, there's no water to go out, so there's no rate. So that just kind of makes sense. A projectile shot upward with initial velocity. This equation came from your notes. That's the one I told you guys to memorize. And they're calling the ground as 0, so there is a plus 0 here that you cannot see. Velocity after 5 seconds. You find the velocity equation, plug in 5 for t. You get 160 feet per second. Acceleration, you find the derivative of velocity. It's a constant of -32. So there isn't a 3 to plug in there, basically. On the last page, ball is thrown upward. This is the equation that you guys got during your notes. When will the ball hit the ground? It wants to know when is the height 0. So I took a 0 and stuck it right there and solved. So obviously when no time has passed, it starts at 0, and then 10 seconds later it hits the ground. At what speed, something velocity, so I've got my velocity equation, will the ball hit the ground? So we know that it hits the ground at 10 seconds, so everywhere I see a t, I put at 10, and I got 160 feet per second. Remember, speed is the absolute value of the velocity. So that's where we're getting the positive numbers there. And when will the ball reach its maximum height? Oh, looks like I didn't finish. Maximum height, I'm thinking that's a turning point. The ball goes up, and then it changes direction and comes back down. So that maximum height is where the velocity equals 0. 60, we subtract 160 from both sides. Divide both sides by 32. I don't know, what is that, like 5 or something? I think it's 5. 160 divided by, yeah. So 5 seconds. All right, good luck on your test or quiz.